All right, we're shooting this ping pong ball into that rolled up piece of paper using a mousetrap launcher. So just go ahead and pull this back, and the paper catches it and it swings inelastically.
The mass of the ping pong ball and paper cone were measured to be 2 grams and 5 grams respectively using an electronic balance. The remaining variables are found by uploading the video tracker and analyzing the data it produced. The velocity of the ping pong ball immediately before the collision, 7.974 meters per second, was determined by locating the point on the velocity versus time graph right before it experienced a significant decrease. The velocity of the ball and bob after the collision, 1.856 meters per second, was found by determining the point when it stopped decreasing by a large amount and stabilized. The maximum height of the ball and bob over the starting height was acquired by tracking the position of the bob for each frame and tracker, then locating the point immediately before the bob started going down. The acquired variables found from the tracker were used to calculate the change in momentum, total energy, and kinetic energy of the system. The change in momentum of the system was found to be about negative 0.003 kilogram meters per second by subtracting the momentum of the ball before the collision from the momentum of the ball and bob immediately after the collision. The change in energy of the system was about negative 0.011 joules and was calculated by subtracting the kinetic energy of the ball and bob immediately after the collision from the potential energy of the ball and bob at the maximum height. The amount of kinetic energy lost during a collision was about 0.052 joules.
For inelastic collisions with no applied forces acting on them, momentum should be conserved. However, in our experiment, momentum was not conserved because there was an applied force. The force of gravity, as well as air resistance and a small amount of friction, were acting on the pendulum and the bob. This caused a change in momentum that would not be there if the system did not have applied forces acting on it. A change in energy across the swing of the bob and the ball was also observed. This was most likely due to the drag of the pendulum due to its shape and how it caught air easily and had a large amount of air resistance. Kinetic energy was lost during the collision, as this is characteristic of inelastic collisions. The variance from the characteristics of the inelastic collision, as when no applied forces are acting on it, are small enough to still retain the characteristics mainly of an inelastic collision and not have too much of an impact on the interpretation of the results. In this experiment, it was learned that during an inelastic collision, generally, kinetic energy is lost and the momentum and energy are conserved. However, when applied forces are acted on the objects going through the inelastic collision, these traits can slightly change.